All right. Yes, sir. Say again? Oh, no. That was an example. I mean, right now, again, if I made a door this tall, what percentage of men would have to duck? 16%. So I could, using what we're going to learn today, I could figure out, well, what height should I make the door if I only want 2% of men to duck? I don't know yet. But I could figure it out using what we're going to learn today. The problem with this is every z-score fit nicely into one of these whole numbers? What was the z-score for this one? 0.42. All right, let's start fresh. Oh, yes.
Is there a way, like, because I know you'll figure out like what the z-score is, but like as for like the percent.
That's what we're working towards.
Okay.
Right now, we can only handle it if it comes out to be 1 standard deviation away, 2 standard deviations away. Why? Because I know the 68% number. I know the 95% number. Are you guys semi with me at all? Are you guys with me? Some of you guys are staring through me. What? So let me catch up with. Did everybody get one of these sheets? Oh, let's see how many I've got. Who needs one of these Mayan pyramid sheets? Here you go. Need one? 3? All right. Printed out more than enough. There's one with a little bit of writing on it. Here's another one. There's one with a little bit of writing on it. Who else needs it? You need it, Nick? All right. Huh? Yeah? I mean, I printed out more than I need to. And all right. Got more than. Oh well, you didn't get one. You have to see me after class. Somehow you guys have treated more people in a very short amount of time. You are freaking me out. Oh, here's one with a lot of writing on it. This got too much writing on it. Oh, all right. You'll have to see me later. We did do some of the other side together, right? At least I don't know. I think we might have finished it. The other side that's got like binomial situation, uniform situation. We finished that, right? Okay. If you weren't here, the answer is still yes. There's a video of it. You go see. All right. It was the other side we hadn't talked about much yet, right?
Yes.
Did we talk about this side? The pyramid side? No. Okay. We will in a minute. Maybe a little bit, because we actually covered most of what it needs to tell me. Let's try this again. So if I have a normal distribution, first off, I know I discussed this. It's not going to be anywhere near as easy as a uniform one to find probabilities of something, right? Because in uniform, finding the probability is just finding the area of a rectangle. You with me?
Yeah.
But if I want to find the probability it's from here to here, I did say this last time, right? There's no geometric formula for that. So then we use calculus to help us out. You guys I did talk a little bit about calculus last time. Okay, it freaked everybody out, but we're not going to learn calculus. All right, stay with me now. This is, I don't know if I told you this, but chapter 6 is the most important chapter in the book. Okay. So, let's say I have a normal distribution with a mean of 80 and a standard deviation of 15. So I can draw this bad boy, right? What goes right in the middle? Which is 80. What is one step up from there? 95. And what's one more step up? Does everybody see where those numbers came from? Can you go the other way for me? Don't say it out loud, just do it. Do 2 steps down. All right. What's one step down?
65.
65. And what's the other step down? 50. Stop. Does everybody see the little numbers in parentheses? Again, remind me, what do they represent?
Standard deviation.
The number standard deviation, so more efficiently I could just say the z-score, because that's what a z-score does. So a very easy question right now is this. What's the probability that I get somebody between 65 and 95? Yeah, why is that easy? Because that is within one standard deviation, and I know that's 68%. Stop there for a second. Is everybody with me? We didn't calculate 68%. We know it was 68% because it matches perfectly up with down 1, up 1. Yes, ma'am.
It's like 65%. Wouldn't it be like 0.65 or 0.95?
What's happening? What do you, no. No. All right. I don't know if I picked bad. These are bowling scores or something. This is like not percentages. These are like bowling scores. Are you with me? This looks more like my bowling scores. Right. My little brother makes money bowling. I'm just happy if I get a few pins down each time I throw the damn ball. So the probability, so if I shade that question in, there it is. That's the area I'm looking for. I don't have a formula for it, but we have a theory for it. We have a law, the empirical rule. It tells me there's going to be 68%. Within one standard deviation of the mean and a normal curve, there's 68% of the data. Can you do this question? No. I like the attempt though. Okay, so let me help you out a little bit. 110 is 2 steps away, right? What percentage is between these two? 95%. So we basically already answered this question earlier, just on the other side. So what percentage is above 110? No, there's 5% outside total. 2.5% on that one side. So these probability questions are easy at the moment because they line up perfectly with whole number steps, and I have a theory that tells me all about the percentages. All right. So that would equal 2.5%. Again, we didn't calculate it because we didn't have to. It just lines right up with the 68-95 rule that we know from before. Here's where that goes to shit. Man, I only got my red marker working. The green. Are you working? What the hell kind of thing are you? Aw, poor little thing. Come here, Blue. What's the probability that X is less than 84? Does 84 match up with anything I know anything about? No, 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 it doesn't. Here's 84, right? So the area I want would be this. That doesn't match up with anything. In fact, what is the z-score for 84? Can you guys calculate it for me? What's the z-score for 84? Well, let's see. What was the z-score formula? You're funky. Whoa, I put it right in my back. Oh, wow. That one went right in my back. So what's the z-score for 84? It's going to be x minus the mean divided by standard deviation. So it's going to be, what's the mean? 80. What's the standard deviation? 15. What's the data point I'm interested in at the moment? 84. 4/15, so whatever the shit that is. It's like 0.26. I don't know, whatever it is. 0.2557?
0.26.
I'm just making shit up. Is it 0.26?
Yeah.
So, what I'm trying to get you to realize, this shape sucks. Big rectangle, good. Finding area of rectangle, good, easy, right? I'll stop talking like that. This shape sucks. The empirical thing helps me out a little bit. If they happen to line up perfectly with 1-2 steps away. So what we're going to focus on today is a tool that will help me fill in all the gaps. For the z-score at 0.26, we're going to have a chart that's got all the answers on it. We just got to find them. This thing, I'll tell you honestly, this is really mostly a review of binomial, and the point I'm trying to make with this sheet, I pretty much already made it. If I have a picture of a probability distribution, the area is related to the probability of that thing. We've already done that to death, I think. That's the main point of this sheet. You can look through it if you want to. I'm going to bring this sheet back up later this semester, though. So hold on to this bad boy. Okay. So, let me give you this. Here it is. Oh, yes.
So, how would you finish that problem? So you found the z-score.
I love it. We can't currently do it. A uniform one just relates to finding areas of rectangles. What would this relate to? This would relate to finding the area of this shape. That shape. I don't have a formula for that from basic geometry. So what I'm going to do, I'm going to give you a chart that if you look up any z-score, it tells you the area below that z-score. Doesn't that sound neat? Maybe I should start selling it like this because I normally don't say that. But that's cool. I want you to realize right now, this is a sheet of answers. You just have to find them.
So you just calculate the z-score.
We're going to do some examples. I got to start just saying that because then students' reaction is better. Like, it should be like, yeah, shit, give me the sheet of answers, please. Instead, I just pass this out being like, what the? Flat job. I don't know if I can count this morning. There's a hidden person right there. I know. See what happens.
I mean, it does make sense. You're actually
Make it so I can just push a button and they'll just fall. Like oxygen masks. Papers fall from the ceiling. Everybody get one? Is it? Did I leave read it out again? God. Absolutely. That's something we talked about earlier. Everybody got one? Alright, so let's figure out how the hell to read this thing. It's like a road map. Or worse. Uh-oh, it's probably gonna heat up in here again, sorry. Such an expertly designed room. So let's first capture something we know for sure. Let's see. What percentage should be below -2? What percentage should be down here? So within 2, there's 95%. So what percentage should be down here below -2? 2.5%. Rounding to 2 digits, right? Okay, so let's see if we can, if I can't get that number from this chart, we'll throw the chart out and we'll go somewhere, get some drinks or something. We can just screw the rest of the stats because they ain't worth shit. So unfortunately for you, it's gonna work. So let's see how the hell to read this thing. So right now, what I want to do is I probably should do it up there since I got the camera pointing at this thing. Queuing for paper shit. Maybe. So right now, what I'm asking is, given a normal curve, what's the probability that z is less than -2? And that's a question we can answer without the chart, but I just want you to buy into the chart. I want you to see it telling me the same thing we know. So we know this is 95%. So this should be half of 5%. It's 5% outside. This should be 2.5% here. Is everybody with me on that? Okay. So let's look it up in the chart. Yes?
Is this for this one or is it separate, like just showing how it works?
What do you mean?
Like, are you doing all of this to solve for that?
So this is the problem I'm looking at right now.
Oh.
Yep. I like it. So, the z-score that I've got, is it negative or positive? Negative. So, see how it's got a negative z-score side and a positive z-score side. Don't you wish I would let you write notes on this? As I say that, realize you cannot write notes on this. You will bring this with you to take tests and so forth, and I will ask you to bring them up so I can see it. If you have notes on it, I'll keep it. Take points off. Yay, Jeff. So don't put notes on this shit. You with me? But notice what's already on here. What is the chart? First off, what's the only kind of thing this chart works for? True, I know it's a z-score chart, but normal curve. It's got to be normal curve because then that's why I know 68, 95 because I know exactly how it's shaped. If it's just some whatever the shit, I don't know, right? You guys semi with me? So it's got to be normal curve because then it's very constricted. That's why it's got to follow that rule exactly. This is basically that 68, 95 rule on steroids. It's just all the little intermediate stuff. Okay. So it's a negative z-score I'm looking at. Secondly, what else? So it only works for normal curves. How do you know? It's got a freaking normal curve on it. And when I look up a z-score, what does it tell me? It tells me the area below that z-score. Okay. Let me stop there. Let you guys absorb that. That is exactly what the chart already tells you. So I can't tell you to erase that thing. It's on there. So just realize that's a note. That's 2 notes. So how do I check this? I want to look up a z-score of -2. Now I had a lot of interesting discussion in my other class. Let me see if you guys are cool with this. How do you write -2 with 2 decimal places?
2 points.
Right? Is that amazing? Okay, shouldn't be. $2 is 2.00. We know that shit. Now, so how do I read this chart? The first decimal place will be here, -2.0, and the second decimal place is here. So I want negative 2.00. You guys with me? So that's 0.0228. Can't see that? Which is not very far off from 2.5. We just kind of like rounded the numbers to make it easier to work with. Rounded a lot, but still. So it's really officially 2.3%. But to make the rule quicker to remember, we made it 68.95. Okay, maybe. So how about this? What about the question we're on right here, the less than 84, this area here? You with me? So I want to find the area. What was the z-score for 84? 0.26. All right, is it positive or negative? Positive. So I know it's going to be bigger than 50% because the mean cuts it in half, and this is above the mean. It should be greater than half. So if you look up 0.26 on the positive side, 0.26. So now we can answer that question. What percentage would have less than 84? 60.26%, yes.
If you had said like greater than 84, would you?
We're getting there. You're just fun. You got to have a little bit of faith in me. We will eventually. I got to start with the basics. Now we're going to start doing some weird other shit. Because this chart is very single-minded. It only knows areas below the z-score you look up. So like Tasneem just said, what the hell do I do if the question says greater than? Then the chart is worth nothing. Well, of course the chart's still worth something. So help me out. If I know now, let me redraw this. If I get this question, this is what I'm going to draw for that question. And of course I already forgot what the mean was. It was 80. Put 84. Shade in the area I want, right? And then this, so when I look it up, I get a z-score of 0.26 right there, and when I look that up, I get, what was it, 0.6026? Okay. So what if the question would have been instead, what's probably x is greater than 84, or where's that on the chart? Where's that area?
To the right.
Yeah, so this would be this area. So if that's 0.6026, what's this going to be?
1 minus.
1 minus
Yeah.
6.
All right, let's do some more basic shit first. I want to address that at the moment. So what about this problem? Oh, we got to stay up there. We got the thing over there. More paper. Paper? No. Paper. Okay. So what if I add this? Okay, I got a normal curve. So if I didn't say it was normal, I can't use that chart. So a big part of basic statistics is, when can I say it's normal enough to use the chart? Later this semester, we're going to be saying that a lot. It's normal enough, thank God. I can now use the chart that has all the answers on it. Okay. So if I just tell you it's normal, sweet. I can use the chart. So what if I ask you, what's the probability that z is less than 2.19? Can you draw that situation for me? Try to draw it. Oh, while you guys are doing that, you got to give stuff out. Morgan, fill out that green thing for me. Go back to Cameron. Same thing, fill out that green sheet for me when you get a minute. Andrew, Stacy. Same thing, fill out that green sheet. Nick. Gabrielle? Manla? Yeah? Gabrielle. We'll let that green sheet get a minute. All right. Yeah. Candace. Cameron. Giselle Gaines. Andrew's not.
So, yeah, it's like, they can't do that.
Yeah.
Well, I think
Yeah. All right. Oh yeah. When you get those green sheets filled out, just bring them up here. So how does this look? What goes in the middle for this one? 0. For z-scores, the mean is 0. Because once I change it to z-scores, it becomes 0. It's 0 away from itself. Where's 2.19? This is the thing that drives me crazy. The picture is supposed to help you. I have people just put numbers just wherever they feel like it. The hell? This is a normal line. You put numbers where they make sense. You don't have to have the scale perfect. As long as you got on the correct side of each other, you're good. Now, where do I shade? Where's the area that it wants? Yeah, did you guys ever hear about that being an arrow that points you in the direction as long as the variable's on this side? That is an arrow. See it?
Yes.
That way. Yes.
So for this one, how do you like know which mean standard deviations you use for
The fact that there are z-scores. Z-scores, what will the mean always be if I've made them into z-scores? 0. Because what does a z-score tell you? How far away from the mean something is.
them?
So the mean will always be 0 if I'm talking about z-scores. This one, the one we did earlier with the 80, that was x-scores. And then we turned it into z-scores. All right, I like it. I like it. So right now what we're really doing is we're focusing on, do we know how to read the chart? Then we're going to do problems where they start off with x-scores. The mean could be whatever the shit, and then I got to make it into a z-score, and then I can use this chart.
For this one, would we have to like calculate x, or like would we?
Coming. You're amazing. You're freaking me out. Stop seeing the future. What's the lottery numbers doing? So how do you get this area? What do you do? Look it up. It's a positive z-score. 2.19, 2.19. So right there, you guys see that? That's the 0.9 over there. So the top row is the second decimal place. So like somebody asked earlier, why do it's 2? We only do z-scores to 2 places because the chart goes to 2 places. And yes, I know if I used the calculator and showed you which buttons to push, it could be more precise, and I give exactly 0 shits about that. Because I still believe that doing it this way gives you a better feel. Once you've done this chart several times, you get a very intuitive feel for how things are set up in a normal distribution. And if you don't agree with that, I don't care. I'm going to make you do this shit anyway. So let's see, where was I? It was 2.19. So that's 0.9857. Are you guys able to find that? And thankfully, so again, the minute I look up a z-score, where do I put it on the picture? This chart tells me the areas that are below. To the left, sure, but I suck with left and right, so I just say below. So I just put it right here and say that's going to be what? What did we just get? I forgot. 9857. Yeah, cool. So that's the answer, 9857. Keep. All right, do this one. Try to draw it at least. So again, if I did not tell you this is a normal curve, a normal distribution, you would not be able to do this at all. Thankfully, I did say these are all normal distributions. It's not a trick question, don't worry. So again, what goes in the middle for this? 0. Where's 0.42? Up here somewhere. If you didn't put it right there, I don't care. As long as it's on the correct side of 0. And now, what do I shade?
Everyone will point towards the left.
Good. So if you are nice to yourself, so do I require you to draw this picture? Not necessarily. But if you don't draw it, you will make really dumb mistakes. But what really sucks is if you don't draw it correctly, you're going to just screw things up for yourself. So don't be mean to yourself. Draw this thing right.
Or put it in the negative. We didn't do that.
Oh. Put it where?
We put it below the 0 just because of the arrow was like messing with
Oh,
the edge.
the arrow tells you where to shade.
Yeah.
So if I look up 0.42, will it answer the question?
Yeah.
No, but we're going to do it anyway because we're crazy. So look up 0.42. What do you guys get? What really, really sucks, by the way, is you notice this has got to be 0.40. But I get so many people tell me this because they go 1, 2. Do you guys see what I'm saying?
Yes.
You got to get a little used to this chart. So that's 0.40, 0.41, 0.42. There it is. 0.6628. Where's that go in the picture?
It's everything's so low.
To the
Right
left.
there. Was it 628? 6628? Is that what it was?
Yeah.
Yes. I used to have something called memory, but. So that's not the right answer. Don't just leave it like that. What's the right answer going to be? 1 minus that because it's the rest. So when you look up a z-score on the chart, you immediately put that thing down underneath what you just looked up. Then you step back and you say, did I answer the damn question? No. So what will the answer to this question be?
0.3372.
Yeah. So 1 minus 0.6628. 0.337